Okay, so number 10, the concentration of dissolved nitrogen in a sample is 10.3 parts per million. What is the molarity? And remember, molarity is equal to moles divided by liters. So what we want to do is we want to find the moles and we want to find the liters, and we want to divide those two. So when you're given 10.3 parts per million, what they're really telling you is that you have 10.3 grams of nitrogen per million, so a 1 with 6 zeros after it, grams of solution. And since it's such a small amount, we'll just say it's grams of water, because the nitrogen doesn't contribute very much to the million grams of water that it's dissolved in. And so since we have the grams of both of those, we can now convert from grams to moles. And knowing and making the assumption that water has a density of 1 gram per milliliter, we can find our liters of water as well, or our liters of solution, since we're going to assume that it's a million grams of water that it would be in. So first let's go from grams to moles. So let's put grams of nitrogen down here and moles of nitrogen up here on the top. And in 1 mole there are 28 grams of nitrogen, which I looked up on the periodic table. And then we're going to take that number of moles and we're going to divide it by our liters. And if we assume that the density of water is equal to 1 gram per milliliter, that means that we have 1 million milliliters of solution. And so this would give us our moles right here. And then we're going to divide that by our liters of solution. And since this is a million milliliters, 1, 2, 3 to the left would give me 1,000 liters. So then we take those moles and divide it by the liters right here. And we end up with 0.000367 molar solution once you run that through your calculator and do the math. Alright, let's see, the next one now we're on to is number 11. A supersaturated solution is, so a supersaturated solution first of all tells you that you have the maximum dissolved solute in the solvent, and then you actually have more than that. That's what a saturated solution is, that you have the maximum dissolved solute in there. An unsaturated solution is one that has less than the maximum amount. You could dissolve more. And a supersaturated solution, that's the one that has more than the maximum dissolved solute, and it still stayed in solution. Number 12, getting into chapter 14 now and some kinetics. So the iodide ion reacts with the hypochlorite ion the following way, and then it gives us some data right here. And the rate law for the reaction is the thing that we're supposed to find. So first of all, it always takes on this form. Rate is equal to some constant K, and then we have the concentration of OCl minus times the concentration of I minus. And these have to have some powers, X and Y, and we need to figure out what those powers are. And so to determine what those powers are, we have to pick 2 experiments and pick one place where, like, iodine doesn't change, but then the OCl does change. And you can see that it doubles from here to here, and you can see that the rate also doubles. And so if one thing changes the same way as the rate does, then we know that it's first order. So OCl is equal to 1 right here, because this doubles and this doubles. And then we need to pick 2 other experiments, and so if we pick 1 and 3 right here, you can see that OCl minus doesn't change, so that's not going to affect the rate of the reaction. But we can see that these double, and that this one right here also from 1 to 3 doubles, which means I minus has the same effect of when you double the concentration, you double the rate. And so that means Y is also going to be equal to 1. And so the rate expression, or the rate law, is what it's also called, that has a 1 and a 1 right here is letter C. So C is the correct answer. And number 13, a solution The reaction below is first order in H2O2, and then it says right here the solution originally has 0.4 molar, and it has 0.1 after 30 minutes. The half-life for this reaction is. Well, remember, a half-life means that half of the original amount remains. So if we have this to start with, one half-life would be from 0.4 to 0.2, and then the next half-life would be from 0.2 to 0.1. And this is at time 0, and then this would be at times 30 minutes. And so every time that you have half, it takes, 2 halves would take 30 minutes, so half of that, of course, would take 15 minutes. And so 15 minutes would be our half-life. And just making a little table like this is usually the real easy way to figure that out. And since it's a first-order rate law equation, you could also go really deep and dive into the equations and find that, but this is probably the easiest way. Number 14, know the half-life equations and relationships for 0, first, second-order reactions, know how to manipulate and solve them. So for that, you'll want an equation sheet, and I think there's one that's included in your packet for the practice test that gives you all the equations for first, second, and 0th order reactions. So that's chapter 15 stuff. We'll come back and start chapter 15. This is going to be chapter 15 right here with equilibrium in the next video.